and I forgot to record. And that's the only thing about these sessions, I think, is it's a little hard to.
I mean, she doesn't have to, because we've been, I mean, I just wanted her, if she wanted to be here, but I mean, if you want, I can just start. Is that helpful?
Yeah, I think so. You know, we have so the other format that we're doing on this, it's probably technically, you know, 13 minutes of presentation and then a couple minutes of Q&A is the idea. But like I said, if we need, and I'll try to keep it pseudo on track, but if we start to go long, I can circumvent my presentation. But let's try to get going, I think.
Well, I use this as an excuse because we're writing a book, and so what you're seeing is going to be the structure of our book. But it's we called it America's Unfinished Business at the Expo, and you'll find out why. So starting with this, and I will promise you there is some entertaining video in here if we don't crash out of it. So we'll start with this topic of the symposium: the intersection of international influence and cultural identity towards social justice, housing equity, and human wellness occurs conceptually and physically at the site of World Expos, which are also known as World Fairs. Historically, these events were the diplomatic grounds at which international communities reflected profound concerns about the future, as well as deflecting criticism of the established political and social order. On the left column, you'll see exterior and interior images of an exhibition at the 1958 Brussels World Expo called Unfinished Business. It was designed by the art director of Fortune magazine, Leo Leone, and it occupied an adjacent site next to the US Pavilion that was designed by American architect Edward Durrell Stone. Its unfolding crystal design was intended to encapsulate America's racial challenges and environmental issues. On the right are exterior and interior images of the 1970 US Pavilion at the Osaka World Expo, designed by Davis and Brody. At the time, it was the largest air inflatable in the world, with interior exhibits displaying artifacts like the moon rock from the recently returned Apollo space mission. Both exhibits were innovative and extremely well received by their intended foreign audiences, a European one for Brussels and a Japanese one for Osaka. Okay, so this is like the entrance, close-up entrance of the controversial Unfinished Business exhibit, and I'll explain why it was controversial. And this is a model of the design concept for the chaotic crystal, which unfolded in 3 sections to show an optimistic transformation. So I'm going to be playing these. So until COVID, I was actually traveling for screenings of our film, Face of a Nation, What Happened to the World's Fair, knowing it would prophesy an internal reckoning of American values and culture. I made the film as the first big step in a decade of research to document the positive impact and critical role of American design excellence in US pavilions overseas through the visionary design leadership of this gentleman named Jack Macy. Jack was the design director of the United States Information Agency, or USIA, and he realized the US pavilions at Expo 67 and Expo 70, as well as others, using architecture to promote general goodwill amongst our foreign neighbors. The film also documents the unfavorable international perceptions about the United States when design excellence is neglected. As part of the country's unfinished business today, I'm going to be presenting a brief glimpse into the scholarship that we will use to make the case to Congress that it's essential for American design excellence to be re-engaged with public funding, which has been blocked since the 1990s. Oh, sorry, it just plays again. So expos and mega events are important opportunities for ordinary people from multiple countries, some who might be distrustful of each other, to engage peacefully with each other around the world on an actual site. to diffuse conflict. Whoops, I'm sorry, I have the wrong page. Sorry. I'm looking at the wrong page. Okay.
All right, Mina, let's.
Yeah. Okay. For some reason, it's printing. I printed it this morning. Okay, yeah, here we go. Here we go, I found it. 9/11 was a catastrophic event that occurred less than 2 years after USIA, the agency responsible for America's image, was eliminated by Congress. 20 years after the 9/11 terrorist attacks, in which iconic American buildings were deliberately targeted, the connection between design and global politics continues to be highlighted in re-aroused nationalism and extreme positions around the preservation or destruction of cultural sites, provocative visual symbolism, and the heightening of identity politics at international borders. The World Trade Center attacks were led by Muhammad Atta, an architectural engineer whose passions were incited by his beliefs in what our buildings symbolized, war and capitalism. These conflicts provoke questions about the visual messages encoded in the creative expressions of our built environment. Okay, so what is meaningful and important to some, yet potentially offensive to others? Are we aware of the possible interpretations or misinterpretations of what society builds to visually represent our culture and assert as its values, and how these declarations may be read or misread? This apparently innocent photo of multiracial children was the apotheosis of Leo Leone's vision for what he conceived reflected part of America's unfinished business. Despite being well regarded by European audiences as the ideal of the American melting pot, the entire exhibit was closed down by the State Department after only 2 weeks due to pressure from pro-segregationist American senators who bitterly complained that the exhibition, quote, did not make the case for segregation. Today, 21st century media technology continues to be double-edged. New engagement platforms in virtual, augmented, and mixed realities, internet, social media, and film have placed a disproportionate value in the virtual, favoring it over the physical space of the real. Media has an extraordinary ability to shape and influence people's thoughts and behaviors. Appearances can be very deceiving. Many of you are probably familiar with these compelling visuals from Steven Spielberg's Ready Player One and Christopher Nolan's Inception, both dystopian films foreshadowing anti-humanistic forces arising when ideology and technology are forced together in isolation. When we overindulge in the promise and convenience of technology, we become disassociated and alienated from each other.
Yeah, beauty.
Today, we are living in a conflicted world where uncertainty has increased anxiety and suspicion. With so many people interacting primarily in virtual space, this gross imbalance has distorted our perceptions of the real world and unsettled our basic humanity. We have become more distrustful of others. A media-saturated world is a place where distinctions between fact and fiction, what is real or merely virtual, becomes blurred. We've lost important corporeal connections to the world, and we're itching to reconnect with each other. So, expos and mega events are important opportunities for ordinary people from multiple countries, some who might be distrustful of others, to engage peacefully with each other around the world on an actual site, to diffuse conflict with face-to-face communication within the last 3 feet. This is a famous quote from USIA Director Edward R. Murrow. He was a legendary communicator. He meant close enough to touch another person in a real place. It's eye to eye, tactile, being there provides corporeal clues when someone or something is being authentic or deceptive. Expos and mega events have always had an important public diplomacy role as a hosted international gathering of nations. Each country showcasing their most innovative design, technology, and culture to persuade visitors that they are the best in the world. What is public diplomacy? Because you guys are architects. So my colleague, Professor Nicholas Cole, who's actually on Voice of America this morning, and so he couldn't join us, he explained it by using this analogy. It's the incentive or method that we use to get a donkey to move in a certain direction. The carrot is an economic incentive. The stick is a military incentive. But persuading the donkey with sensory, visual language, and ideated words is public diplomacy. Mega events and expos are multidimensional platforms for public engagement, requiring meticulous and strategic levels of communication in all languages: verbal, written, visual, and tactile. Architectural expertise provides important insight into the immersive virtual and physical realms that we live in, which is why architecture is so important at an expo. Architects are adept with using the three-dimensional haptic language of form, space, and order to affect people's understanding of the world and each other. Designers are the interlocutors navigating between the realms of geopolitical influence and creative ingenuity. USIA's design director, Jack Macy, was so successful with his work at Expo 67 and Expo 70 because he knew that the most creative people were also the best problem solvers. Jack also understood that architects use the substance and form of our kinetic waking world to kindle human emotions, a powerful persuasion without words. Design excellence moves people in more ways than one. The highest quality design at world fairs is an important opportunity to influence and reshape in our American story with international audiences on a real world stage. So this video clip shows the construction. It's actually rare archival that we had restored. And it was used at the Biennale in 2014. I contributed it with Beverly. It was under the Macy archive, and she's here with us today. So from the US Pavilion at Osaka, Expo 70 in Osaka. It was the most technologically sophisticated and least expensive US pavilion ever built by the United States to this day. The largest clear span structure in history at the time, and it only cost $1.25 a square foot for a total cost of $9 million from site preparation to interior fit out. Sorry, it does that. So design becomes excellence when its work confronts and inspires humanity in profound and profane aspects of existence. Some in this country, like Congress, have underestimated the influence of American design excellence. The remarks on the screen are from a USC Public Diplomacy Zoom panel from last year. They are legislative staff members' responses to my direct question to them about why public funding does not exist for overseas Expo US pavilions, despite the other 190 countries of the world having major support from their own government. They said they have not seen the data and it's hard to quantify value. So an amalgamation of data, including primary sources from USIA surveys and polls, neuroscience, press reviews, architectural theory on media, and the simulacra are part of the work that we are assembling together. We want to raise awareness with Congress that American design creativity is an undervalued natural resource in the United States. It's there if they want to look for it. It's there if they're looking hard enough. We're making it easier by putting it all together for them in a book. So this is our team. Complex issues require interdisciplinary collaboration. Our research recognizes the need for newly concerted efforts and creative approaches between the communication realms of public diplomacy and design. Critical to this effort is raising awareness of the fundamental and underutilized value of architecture and design. By preparing interdisciplinary students to work effectively at this confluence, which is what we got the grant for, challenges between these realms may be better understood. So there's some awareness now in the State Department of the wide-reaching influence of architecture and design because of the film that we made and the Macy archive, which are both listed on the State Department website. Our team has been assisting the State Department's Expo unit in their efforts for the upcoming Dubai World Expo, which opens in October 2021. But there remains a need to extract and aggregate the existing data from the work of multiple disciplines. This is the work of our team. So we look forward to reporting back to everyone about our progress.
Great. All right, Mina. Thank you.
Sorry, I had some technical difficulties because
I think, can you stop sharing perhaps, and then we can, we're gonna have to keep rolling along. And we're gonna go to Minghu, who is joining us from the University of Maryland. And I already did give a brief introduction though too. So Ming, if you can take it away.
Sure.
And pardon my, I'm trying to keep this a little bit on track though too. So I think we're actually 15 minutes behind. So hopefully we can scoot up with time frame for most everybody, if that's possible. And as I said, if we really get down to it, I can give a 2-minute presentation on mine.
Okay, can everyone see my shared slides?
Looks good.
Okay, so hello everyone. Today I'm going to present my group study on built and social environment impact on COVID-19 transmission. My name is Ming Hu. I'm assistant professor at the University of Maryland. And our team also includes Dr. Roberts, who is a public health researcher and 2 graduate research assistants. This particular study compared COVID-19 outcomes across a range of housing, living, and social conditions in Washington, D.C., which is one of the regions in the United States with the highest COVID-19 cases and deaths per population since the onset of the pandemic. In the past couple decades, the focus on the association between the built environment and the public health has been mainly focused on chronic disease, such as obesity, heart disease, rather than infectious disease. There have been studies on indoor air quality and the subsequently infectious disease. However, very few research sought to study the connection between building physical and structural condition to infectious disease before the outbreak of COVID. Since the beginning of the pandemic, there has been a surge of research focused on the impact of built environmental factors like indoor air quality and building design in the transmission of infectious disease, environmentally mediated pathways. And most studies have focused on the strategies for reopening office buildings and schools. So we recognize there is a research gap and a needs to study residential buildings and their relation to the COVID transmission. Because in the foreseeable future, the majority of people will continue to work from home either entirely or partially. Therefore, it is essential to understand the influence of housing quality on public health in the context of COVID-19 in order to provide knowledge and insights to policymakers and other stakeholders. To the extent the study addressed such gap by examining association between the built environment and social economic factors with COVID incidence, mortality and fatality rates. So we use the built environment and the social environmental data extracted from the Washington DC energy benchmarking database and American community survey database. More than 113,000 housing units were analyzed against the COVID case counts, death counts, mortality rate, age-adjusted incident rate, and the fatality rate data from DC Watts. For those of you, most of you are not familiar with the DC terminology. As you can see on the screen, the lower right map showing the DC is composed of 8 different watts, which is a different boundary from the typical district or neighborhood. A 3-step analysis process was used. First, we create the multivariable regression models for built environmental factors and the social environment factors. Second, the most influential built environmental predictors and the social-economic predictors were combined into a final multivariable regression model to study the dynamics of those predictors to the relation of COVID outcomes. And lastly, the combined model is tested at the neighborhood level and used to predict the future COVID outbreak in Washington, D.C. at the neighborhood level. So in this study, 7 factors used to index built environment and the housing quality. They are housing age, housing size, housing energy efficiency, crowding ratio, green space ratio, DC student who lives and attends school in the same Watts ratio. And lastly is commute time to work. The commute time to work from the home. In addition, 4 subject areas, social, economic, and housing and demographic, were combined to index the social environment. Altogether, 8 social-economic variables were identified. They are Black American ratio, median age more than 65 years ratio, median household income, poverty rate, family to non-family house ratio, foreign born ratio, and lastly is essential to non-essential work ratio. So those are all the variables we included in the multivariable regression model. And here shows the housing character data. And those data were downloaded from the DC Energy Benchmarking database. In 2008, DC passed the Clean and Affordable Energy Act, which requires that all buildings with a gross floor area of 50,000 square foot or greater to report their actual building energy and water use annually. The benchmarking is done according to the Energy Star portfolio manager supported by the U.S. Environmental Protection Agency. This method makes it possible to determine each building's age, size, location, and current physical condition. And we actually use the energy use intensity as an indicator for the current building physical condition. There are altogether 672 multifamily buildings around more than 30,000 units are reported in the 2019 DC Energy Benchmarking database. And so for the social demographic data, they are extracted from the American Community Survey. And those data calculate age, race, occupation, household composition, commute, and crowding ratio at the Watt level. And for the COVID data outcome, which is those maps showing on the screen right now, it was extracted from the DC government Corona's online dashboard, which published the daily on the daily basis, like you see on the screen, those are also at Watts level. So now let's look at some result. First, let's look at the DC housing characteristic. As you can see on the bar chart on the screen, the Watt 2 provides the most units, followed by Watt 6, Watt 3, and Watt 1, respectively. And the most common housing type in Watt 1, 2, 3, and 6 were high-rise multi-story multifamily housing, which were accompanied by a relatively low crowding ratio. On the contrary, Watt 4, 5, 7, and 8 had predominantly a single-family housing type, but with higher crowding ratio. And specifically, and especially if you look at Watt 4, Watt 4 has the fewest amount of housing units, but with the second highest crowding ratio in Washington, D.C. Here is an important concept I want to clarify. Since from the beginning of the COVID outbreak, urban density has often been discussed as a negative and damaging factor. This is not exactly true. Crowding ratio actually has direct correlation with the COVID outbreak. Density is the measure of the built area within a given boundary, and the crowding ratio is a measure of space each person occupy. Our study and other studies all showed the crowding ratio is the influential factor rather than the density. Next, let's look at this table. So this table shows the housing quality, living condition, and the travel pattern for each individual watts. One thing is worthy to note is that for median housing age, Watt 6 had the newest and the largest building stock, and Watt 1 had the oldest housing stock and the highest energy efficiency. The highest energy efficiency is represented by the low EUI, the energy use intensity. This was an indication that those older buildings in Watt 1 actually underwent major renovation or upgrades. Hence, it is very possible that those older building units actually has a better physical condition than those of newer buildings in other watts. And this slides just to quickly show you, those are 3 separate regression models we created and used for the built environmental factors analysis. And we create another 4 regression model for social environmental factor analysis. And here shows the regression analysis results. The upper table is for the built environmental factors, and the lower table is for the social environmental factors. The most influential built environmental factors are 3 housing quality indicators. They are housing age, HA, housing size, HS, and housing energy efficiency, HEE. And the crowding ratio and the commute time also show the statistically significant to the COVID death count. The most influential social environmental factors are Black American ratio, household median income, and essential worker ratio. Those 3 also relate to the COVID death count. We also found in DC watts we found those DC watts with poor built environment, especially housing quality, were found to be associated with the higher COVID death count, even after adjusting for individual risk factors such as race and household income. Our study did not show correlation between any other factors to other COVID results, such as mortality, age-adjusted incident rate, and fatality rate. We only found the correlation between those factors to the death count. And after determining those significant influencers and factors, and we use those as predictors, we combine those 5 factors from the built environment and the social environment together. Housing age, as you can see on the screen, housing age, housing size, housing energy efficiency, crowding ratio, and the black ratio to create a combined regression model. Then we extracted those data of those 5 factors at the zip code level. Previously, the previous study is based on watts. Now we are get down to the zip code level. We try to predict the future hotspots in terms of positive counts using the death ratio. And the right-hand side, the right-hand side image is the heat map of a potential positive case account. The color shows the brownish, yellowish color. And the potential positive case account was simulated, estimated from the combined regression model we created at the zip code level. The darker the brownish, yellowish color, the higher the potential case account. So the hotspots we identified.
My apologies, but we're gonna have to keep going. But in about 2 minutes, can we try to wrap it? Great.
Sure.
Thank you.
Okay. As you can see, the hotspot identified by our model is slightly from the left side image, which is actual case account back in August 2020. So you can see we identify additional hotspots, and the zip code has the highest African American ratio, and also has the highest essential worker ratio in Washington, D.C. And quickly wrap up, after we published our study, we reached out to variety DC agencies and the commissioners in all wards to promote, try to ask them to allocate more resources to those potential hotspots we identified. But as you can see here, this is a map. The grayish map is the map I extracted last Monday from DC website, illustrating the percentage of the residents actually got the vaccine, got vaccinated. And you probably, if you still remember the left-hand side, and this is an actual count and a prediction count, which is pretty accurate. And compared to vaccination count is almost the opposite, right? So those not hotspots get the most vaccination. We don't really have good explanation and insights about this mismatch. But one data and also one data set might not be telling the whole story. We only hope, we can only hope the DC mayor and her administration can be on the forefront to create equitable access and care for all DC residents. That is my presentation, and we can discuss later if you're interested.
I think that's the discussion will be at the end. Actually, is what will happen if we have time. But moving on, we're very good. Thank you, Ming. So Meredith Drake Ritdan, who's a lecturer at USC, will be giving her presentation on Bunker Hill Refrain.
Thanks, Scott. And thank you so much for this opportunity to talk about the Bunker Hill Refrain project. And I do also want to acknowledge the support from the School of Architecture and the USC libraries that made much of this research possible. And just to make sure, okay. The funding from these two sources enabled us to bring together a group of students from across the university, including the Price School of Public Policy, students in the Masters of Heritage Conservation program, as well as myself and librarians. And so the Bunker Hill Refrain project is taking another look at a very familiar site to many of us in Los Angeles. For those who don't know, Bunker Hill is a part of downtown Los Angeles, originally settled 1870s, 1890s. The mythology of Bunker Hill is these sort of lavish Victorians In the 1920s, the hill was decided and determined to be an impediment to progress as the city of Los Angeles was moving south and west. And from that point on, the area experienced a significant sort of disinvestment. It became home to primarily working class families. At one point, it was the densest neighborhood in the city of Los Angeles. And the myth of sort of film noir, it's a classic example of LA's sunshine and noir story. In 1958, the hill and much of the, well, all of the housing on top of it was demolished and replaced by sort of corporate towers and elite cultural institutions. So we're taking another look at this particular history. And part of what we're doing is recentering the story on the everyday lives of the individuals who both lived on the hill, but were also displaced. So the estimates are kind of unknown at this point. It's anywhere between 6,000 and 9,000 individuals were displaced when Bunker Hill was destroyed. So the Bunker Hill Refrain Project allows us to kind of retell that story from the perspective of those who have not actually been part of the conversation for many years. So we're looking at sort of a couple of key items. Can we tell a different story about urban renewal in Los Angeles by thinking through the outcomes for the people who lived on the hill? Can we think about the social cost of this particular planning idea rather than the architectural loss, which in some sense tends to dominate our current mythology of Bunker Hill? As a practicing planner, I'm also really interested in the idea of using digital tools to potentially reconnect a displaced community. And can we also envision a different kind of planning practice that might emerge as we think about the way the past was enacted? I also want to suggest that, you know, this actually isn't necessarily a story about the past. As we consider massive investment in infrastructure spending, as we continue to fund highways and displaced communities through other mechanisms, what can we actually learn that could help us rethink planning going forward? And I hope that part of what we do contributes to that conversation. So the project has two phases. We started with a snapshot moment. In 1939, the Works Progress Administration conducted a survey of the city of Los Angeles. They went door to door and collected information about housing, the dates of construction, the kind of amenities that were available to individuals, and also race and ethnicity. Those WPA cards, the sort of material cards, are archived at USC libraries in the special collections. In the 1990s, a number of them were digitized. So there's about 1,000 it's about 5,000 that are in the Bunker Hill area, but there's close to 1 million cards that are available. And so in order to access the data that's available on these cards, it's all handwritten. And so a number of us have looked at these cards over the years and tried to figure out how you could actually access all of this incredibly rich data. So the team has developed a crowdsourced transcription site using the Zuniverse platform. Zuniverse is, I think it started where you could kind of count penguins. It's a crowdsourced citizen science application. And so using it in the context of libraries and public history is sort of a pioneering new tool. So we've set up this Zuniverse site. We have about 100 volunteers. We're in a beta phase at the moment, but we've also identified 500 cards that are within the Bunker Hill redevelopment zone. And at this point, after about 3 months, we have 300 of these cards actually transcribed. So this data is going to be available publicly. We're going to post it so that it can be analyzed by scholars in the future and sort of remixed for all sorts of new stories emerging from this particular moment. The second part of the project is thinking about putting that snapshot in motion. So we're taking that 1939 moment and cross-referencing it with other primary sources. The Masters of Heritage Conservation class this semester is looking at the US Census. They've conducted interviews and oral histories with the descendants of the displaced. They're looking at building permits and the sort of Sanborn maps. As you know, the semester is quickly coming to a close, and so many of those projects are going to be student final projects that will be available in May. But we have been able to identify a number of individuals who grew up on Bunker Hill or who were affiliated with the Hill. So students are involved in collecting those oral histories. And we're going to build a website that actually documents all of these findings. Just want to sort of the tantalizing information that has been emerging so far. We've been thinking about this idea of residential trajectories, the historical residential trajectories. And this is a mock-up of a map that we will be building. And this represents one street on Bunker Hill. It's called Cinnabar Street. And Cinnabar, there were two houses, both of which were occupied by widows in 1939, one of whom had emigrated from Sweden through Canada, Montana, and ended up in LA in 1939. Another was born in Tennessee and moved across the country. Her son was born in Iowa and then ended up in LA in 1939. So we're thinking about sort of mapping where folks came from and also where they went after their life on Bunker Hill. So there's a couple of things that you know, as we're getting involved in this project, it turns out it's a lot harder to find where people went after the displacement. And part of the reason for that is the 1950s US Census will be available in 2022. So we already know that this is going to be a project that's going to take us a little longer, that the historical timeline has been extended a little bit. But we have been deeply involved in Ancestry.com, and so we're building the maps that are available at the moment. I'm also sort of theoretically thinking through what this actually means in a heritage conservation context. There's a long literature that suggests that digital methods democratize heritage engagement. I'm not totally convinced at this point that that's actually the case. In some sense, I think that technology still remains a barrier rather than an entry point in this particular way. Zuniverse, despite the sort of large crowd, it still remains expert driven in that we have to kind of set it up. The data, when it comes out, is not sort of easily accessible. It still requires somebody who knows Python. And so there is sort of still a pivot point that I think is to be explored. I'm also really concerned about sort of who is the crowd in the crowdsourcing idea, and how do you actually get beyond the sort of nifty techie stage to create projects that have more meaning in people's lives and more meaning for policymakers, which I think is something that both previous speakers have kind of wanted to do. So this is very much a work in progress. Thank you for the opportunity to actually speak and talk a little bit about it. I'm excited to sort of think through the other things that come up out of today's session.
Meredith, fantastic,
Thanks.
very good. That's very interesting. So I think, again, to move things along, I think Doris will be making her presentation. Obviously, associate professor, she's chair of the undergraduate department on wellness, public health, and facade design.
Yeah, can you hear me? Yeah,
Perfect.
right. I'll try to go through this fairly quickly. again, I tried to make the topic relevant, or my lecture or presentation relevant to the topic. What I'm going to do is I'm going to show you a little bit of the background, the idea behind it, as well as some of my previous work, and then some of the current work that I'm working on in this area of wellness. To give you a very quick background on how I'm thinking, I think that the architecture field is very correlated to the food industry, and a very, very quick historic view of it. Again, the beginning of time, food was basically used for fuel. And this is, again, a very, very quick overview. Then there's, as the culture developed and the world became richer in many areas, the food then became part of gluttony, right? It was this luxury item that the more you have, the better it is. And the quality also increased in that area. But more recently, the idea of food as nutrition is something that becomes more important, right? The organic food, the different types of diets out there, all these things of how we really have to think nutritiously, possibly as a result of the gluttony period before. Architecture is fairly similar. In the beginning, again, for a very long time, it was just made for shelter in itself. Then there's an era that architecture was for the luxury. Is like, where can architecture go? And these ideas went beyond into ideological areas, etc. And then more recently, this idea of architecture for wellness. Again, I'm sorry, I'm just moving very swiftly through these portions just so that we can get through all the presentations as much as possible. And so this is the area that I'm also working in and looking at very carefully in my design research. The work itself is looking at how architecture can be responsive to the environment in different ways, right? And so for the first part of my work, for many years, I worked with the thermal bimetal material, which basically responded to temperature changes on the outside so that when the temperature went up, the material curled. And so I looked at trying to make surfaces ventilate so that they can self-ventilate and allow air to pass through so that we're not dependent on expensive air conditioning systems to do so. Looked at systems of shading, how to control and modulate shading so that these two types of systems can then be used in facade design so that they can, as the sun moves across the sky, change, control the amount of shading, increase the amount of self-ventilation, and therefore reduce the need for expensive air conditioning. More recently, I have a product called Invert self-shading windows, which inside the cavity of the windows, we put this thermal bimetal that basically flips when the sun hits the surface and automatically shades. So you can see we have installations here on the right at Brooks.
I already talked to Jennifer. We're just going to send them the planning stuff. We're not sending them the base. They're going to trace our drawings, whatever they need.
Someone has someone's talking?
I got it.
Okay. And you can also see here another installation at Cal State Long Beach. Sorry, that one's a fairly quick one where you can see the material flipping as the sun goes across the surface. More recently, and this is where the funding recently was put into, is in smog eating panels. This does not use thermal bimetal, but a different system. So working with a group of experts in USC, ranging from aerospace engineers to public health experts to public policy makers, and trying to look at how facades of buildings that are typically used just for the building itself can be used for the public good, so that the outside or liminal surface of architecture could be thought of as infrastructure as opposed to branding. In this case, as you know, in the urban canyon situation, the particulate matter sits at the very lowest part of a street area. And so this is also where pedestrians are walking at all times and therefore getting the worst amount of exposure to it. And so lung disease is going up in these cities as we go. And how do we deal with this, at least on a passive level? And that's what we're looking at. So using chimney effect, as well as Bernoulli's principle, working with aerospace engineers, trying to find ways to move air through a tube so that we can filter it on one level, and in other areas have air residing longer periods of time to interact with things like titanium dioxide. So in doing so, we built our own wind tunnels. We also have access to the wind tunnels at USC, but they're moving a little too fast and they're too big, so we had to build our own. We have now built through resin printing a prototype, which is about 6 feet long. You can see here. Sorry, I think the sound is on a little bit. You can get a little better view of it up here on the top. It's actually sitting inside a portion of our wind tunnel now, which we had to elongate. The wind tunnel is made out of plexiglass. The reason why we 3D printed that tube in resin is so that we can actually, when we do the smoke testing, see the smoke move through. The dilemma, as it is for many people, is that during COVID, we were not allowed to test it. And so we have not been able to test this for the wind tunnel for the last year. So we're still waiting for that. You can see here, we're looking at how to array some of these tubes, how to control them in different ways to maximize and optimize arrangement. We've worked through some 3D modeling tools to do that. The hopes eventually is to apply it to buildings. Sorry about that. Let me go back. Apply it to buildings. We want to make fresh air pockets. You can see this out of bus shelters, and are trying to partner with automobile companies so that they would be able to fund these bus shelters as opposed to a city, since their automobiles are the ones who are emitting the smog. And to also apply them to building facades in rain screen type of fashion. The last project I'll show you very, very quickly is looking at how to deal with mental health of the city. This is one of the projects that I worked on previously, and they're ongoing, is I make these little critters, and they are very, very mini robots that actually act and propel by themselves through temperature change. So you can see that these things start to move and they start to roll and scooch, and we've made many of these things. And the thing that was interesting about this is people have a very emotional reaction to them, right? They smile, they're cute, we name them, they almost become like little pets of ours. And so in doing so in a lot of my work, we realized that this can actually really affect architecture. And the way that we make architecture dynamic can be a responsibility of architects, because we can also make them negatively too. So there's a certain amount of control that we need to have for that. And so this project, which is funded by several other organizations, is in pursuit of joy making, right? Of how we can use these things to contort facades in such a way that people do smile. And if people smile more, their endorphins go up. If we can make 5, 10, 100, 1,000 people smile a day, we can possibly improve the mental health of the city. So this is in the beginning stages and trying to make the muscles move on buildings in such a way that they perform not necessarily for cooling or heating or technical reasons, but for the purpose of mental health. So that's my presentation.
Doris, awesome, very good, very fascinating. So we're going.
I made it fast.
You did it. Thank you. And we're moving to Jen Siegel, a wonderful colleague, adjunct professor on a generation model of the death of distance.
Okay. Can you see that, Scott?
Yeah, it's on the presentation thingamajigger.
Everyone's on the presentation. Oh.
Yeah.
Hang on a second.
I don't.
Screen. There we go. Yeah, I think it did. So, how's that?
Looking great.
Okay, thank you. So pleased to be here. Thank you for moderating a great group of people. The title of my talk today, Generation Mobile, The Death of Distance, comes originally from an article from The Economist in 2008, and very much at the forefront of thinking of things to come. I've been looking at mobile structures since the start of my career in 1998. There's an amazing array and history of things that are movable, truckable, deployable, demountable, what have you, that often are associated with alternative material types as well as energy systems. Mostly I've been thinking about ideas of astronauts, hermit crabs, and ideas around archigram. So studying the astronaut, we come to realize that she is ultimately very much defined and limited by her gear and supplies, that the astronaut must bring oxygen because they cannot rely on the environment that is provided to them. So it has, while mobile, has limitations. The hermit crab is also an interesting example in mobility. Its mollusk shell is carried on its back and used as a protection or shelter device. The more recent kind of urban nomadic warrior would be someone with a carry-on bag on an airline, stuffed full of wireless power banks, USB cables, dongles, AirPods, and presently your mask and hand sanitizer. And then ultimately, I think the next step in that trajectory was Michael Webb from Archigram in 1964 and 67, the Kushicle and the Pseudoloon, ideas that had more to do with connectivity and plug-in systems where you take with you your chassis and your inflatable envelope, where you find comfort in the wilds of urban lifestyles. I believe that there's this idea that we are now in, which has more to do with a permanent connectivity, not necessarily motion, but the critical position is about connectivity. Here, Manuel Castells, a sociologist at USC Annenberg School of Communication, and along with Razorfish, is kind of explaining this idea that we are now truly embedded with the future of technology within our skin systems. So OMD, Office of Mobile Design, my firm, has been thinking about these ideas for a number of years, whether they have to do with the rethinking of a Bambi trailer, or even inhabiting space in the ocean, where I'm considering a variety of different materials that range from aerogel to technogel and Luminix, things that are much more future thinking than we necessarily are at in 2021. Although at the time when those were designed, I was thinking we would be further along in the building industry. I'm often challenged by living in Los Angeles. I really appreciate this quote by Benjamin Bratton, where he talks, Joan Didion quote, where she says that this revelation is the most authentic Angelino social experience is that we are not going to any place all lined up behind our windshields, but we are already there, which then made me, kind of brought me to this realization that, if we're not in the future, how can we get to the future? And what are the qualities of our buildings that need to be addressed? The question that Fuller raises, Madam, do you know the weight of your house, is something that I have been challenging myself to solve in a variety of ways for the last 25 years. Some examples of that work and that mode of thinking I practice on myself. This is my house in Venice, where I'm using a truck to kind of inhabit a space or create a new environment in a kind of simple and lightweight manner, using an upcycled or recycled truck material. I then started to think deeper about manufacturing and how am I going to address these materials these technologies and ultimately manufacturing? And the answer was factory built systems for me. And that led me to modular construction. Here is an article from Esquire where I'm starting very early on to think about taking a factory built manufactured classroom and transform it into a house. From that, I started to consider, how do I take better materials to the factory and transform what they're already doing to make something that would be considered architectural. This was a showroom that I created in Venice using a variety of different materials and some off-grid systems, more passive systems, different materials like polycarbonate and bamboo, but ultimately just thinking about space and form and how do I make bigger windows with boxes. These modules can be moved, they can be trucked, as long as you don't exceed a 16-foot width. Length is not as much of a challenge, but height is also a limitation. So this module ended up being located from Venice to Joshua Tree, where the client set it up in an off-grid manner, since he at the time did not have access to power and water. And then another example of that same idea, working with a group of students at Taliesin, or the former Taliesin, I should say, another single module that could be sitting in the desert using power from the sun to create energy. That same idea plays out again in a house that OMD created in Big Sur, where you can see the development of the thinking, like how do we not only get energy from the sun, how do we create a fully off-grid system where we're storing energy in battery packs. This was a house that was lost in one of the fires, and how do we create more fire-resistant environments for the future? That subsequently led me to thinking about multi-modal systems as well as multi-modular systems. If I was to bring together a variety of different materials and boxes or modules, what kind of environments could I create? Here's an example of what it looks like in the factory when you're building a single module. They're splayed out. Even though they could be 2 or 3 stories high, it's always built in at one single level. These modules, are as much as you can do in the factory, even though it's still hand tooling, is ideal. And then they are typically trucked and craned into site. This is my house in Venice that is 3 modules that were added in a vertical fashion and attached to an existing structure. And then I started thinking more about the materials and the manufacturing, and how can I work with materials that not are just environmentally sustainable, but also stronger. And since most people can't afford titanium, we've been testing things from SIP panels to now I'm looking more into mass timber due to the fact that I'm teaching that topic this semester. So I'm becoming more and more interested in how do I develop a greater palette of materiality. Ultimately, the future is about manufacturing in a variety of new ways, because swinging a hammer on a job site versus swinging a hammer in a factory, you have more control, you have less waste, you have a faster turnaround time, but you're still swinging a hammer. Ultimately, we need to be thinking about fully automated manufacturing systems. We know that we can do this, we know we can print, we can extrude, we can fold. You just saw examples from Doris's work. We can have materials that are more responsive to their environment, but how are we going to be dealing with these issues? Water, one of the most precious resources we have, is something that we need to be harnessing in a new way. Power, obviously we have this incredible source, the sun, that needs to be harnessed. Waste, other than outhouses and large wastewater treatment plants, how do we deal with human waste, gray water, black water, and communication? One of the disadvantages during the COVID moment in time is the lack of resources or the lack of connectivity that so many students have had, which we've all experienced. And that is really a huge divide. So thank you, Elon Musk, for putting some money into this idea. So the future of Starlink is now available to us at $99 a month. We can be in a more remote setting and have roadblocks. Delivery systems are the next idea that I've been considering. If we're going to be thinking about drone technology and moving off of fossil fuel, moving away from trucks and even cranes, how can we use air systems to be delivering our structures? And then I'm going to leave you with a couple ideas that I'm now presently working on, which is part of my grant, which has allowed me to amass all of this research and thinking about materiality in a new way, thinking about how we ultimately put structures on the ground, and how our homes will ultimately be fully off the grid, bringing water from the air, recycling their own wastes, and getting energy and telecommunication from the sky. This will be the launch this summer of a project I've been working on for the last 6 years, a company called Wildernests, and we're super excited to see the future of materiality, manufacturing, and deliverable systems. Thank you.
Jen, super exciting. That was very good to see. I, again, am going to try to move things along, and let me see if my, sometimes I have issues with the PowerPoint. So I'm going to try it with PowerPoint first and see if this works. My discussion is with a slightly obsessive thing I've been working on for a few years called Do Pneumatics. It's a vacuum metal panel in this case, the two. Everybody can see my screen, correct? I'm going to just assume that's correct.
Yeah.
So as an office, Baumgartner Uriu, we have been working on a number of different typologies and different projects, ranging from scales of an aluminum chair in this sense to a giant park in San Jose that we actually made it into the top 50 out of 900, and then also working with ceramics and all sorts of different materials. So the materiality in our office is a ever-going exploration. We have our own couple kilns in there, and we have 3D printers, we have CNC machines. There's always been a obsessive quality within our own work of exploring many of these circumstances. This is the aluminum chair up here, etc. But again, the idea of robotically controlling these things, taking a look at ceramics as far as a very fire protective type of system for fires, etc. But today I'm not going to talk about any of this. What it is, and Greg actually mentioned this, is that by 2060, and the estimates are here and there, but it's about 2.4 trillion square feet of space will be built, basically doubling the square footage on Earth. And even though it's a CO2, it's a huge CO2 problem, obviously, the majority of the CO2 problem, ironically, is not transportation, et cetera, it's actually buildings are the main purveyor of CO2 and energy, carbon dioxide emissions itself, that too. So there's various examples of the energy consumption per capita. Obviously, a lot of the countries that are doing this are under harsher conditions, though, too. Iceland, Canada, et cetera, Norway, than the US. But it tends to be basically an idea of the 40% annual loss of emissions and energy is mostly an issue with walls, roofs, building envelopes is really what it is. So if we don't really address this soon and quickly and very well, we're going to be in trouble. So anyway, what I was looking at is the idea of a vacuum, basically, for insulating panel, which, again, creates the most ultimate thermal insulator, but it also creates, ideally, an ultimate acoustic insulator as well. So you can solve two of these things simultaneously is the concept of this. Also, there has been vacuum panels and vacuum insulated things before, but they tend to be sort of one-off, where you vacuum it once, it's wrapped, and the idea is that it stays only for a few years, or only for a certain time in its vacuum state. That is, these windows, they'll leak after a few years. The vacuum panels systems tend to deteriorate after, under a decade. Then I started looking at the idea of ETFE, and currently ETFE, of course, is a pressure system, but what if that were reversed? And some of this has been looked at before, but quite honestly, as a vacuum system, it's always been a sort of a structural thing per se, not necessarily an environmental system as far as that goes. But again, ETFE was sort of the original set of circumstances I was exploring at USC. There's been all sorts of, to the chagrin of some of the maintenance departments, a number of seminars and studios that I've run at USC, exploring mostly the concept of it and sort of the digital and physical replication of some of these systems. In the summer of 2019, with a couple of undergraduate students under a grant, I also was able to explore different possibilities of these and making these into testable mini mock-ups of some of the envelope systems themselves too. And again, how they would react and how some of the forming would react under vacuum pressure itself too. And it was with a fairly rudimentary sort of system of testing with microphones and with temperature gauges, we were able to determine that these systems work pretty well as far as keeping out hot air and acoustics out of these envelopes with a simple vacuum. Again, in the fall, I ran another studio that was taking a look at these things, again, in a fairly expressive way, not necessarily fully in a pseudo-technical sensibility, though, too. And a lot of these systems were sort of double systems where there was interior objects, it's sort of the spacers in between these things that allow for the vacuum paneling to work, etc. And again, in a plastic format is where we were going. Obviously, these are hand done, and it was really evident that the vacuums were not, extremely well sealed, etc. And to pursue this further, what I ended up doing is talking with Zahner Metals, and I have a pretty good relationship with Zahner Metals. They are from Kansas City, a incredible manufacturer in that region, and quote unquote around the world as well. I've worked with them on a few of the Frank Gehry projects that nearly bankrupt them, on at some point, but they are a fantastic metal company, and really into the idea of experimenting with metal and seeing what you can do with it. And there's a number of people at that office as well, besides Bill Zahner, but this is Berchan Nasili, who's a next student of mine as well, and ex-employee. What Bill has been doing with this artist, Hilgerman, was doing these sealed metal, stainless steel metal objects, and then vacuuming them out and crushing them from the outside pressure of it. And so what I've been doing with Bill is experimenting on creating some sort of vacuum panel system that is hermetically sealed. There's a number of issues that we've gone through with this system, the different sort of design formats, but also how to create a joint that is not thermally transmitting, if some of the panels need to be thicker or have an internal egg crate or something of that nature. And we've basically also played with the proportions of it to allow a sort of systematic way of putting this together. The idea is also that it's a very simple system that you could take it apart if necessary and recycle it later in life. The back panel was, this big flat thing, but by actually, deforming it with these, in the same method that they did for the Herzog and Demeron thing in San Francisco, they were able to strengthen the back of these panels to allow for a vacuum to occur in the two. And again, it's a simple sort of system, but allows multiple different ways of putting this together, and different configurations is the idea. And as I said, the idea is also that it's meant to be taken apart later if necessary, though, too. So the vacuum panel is pretty simple. It's a one sheet, so far 16 gauge metal. They're testing it out. They're putting it together out there, and that is where it is. The idea is that once I have this back in my hands, we'll test it as far as the rating of this goes and how much energy is required versus the vacuum impact of it, and then possibly go after all sorts of different grants with this in mind. And that is a pretty good elevator pitch for this, too. So, hey, I think we're actually right on time, which is kind of crazy. So I was wondering, we have 15 minutes of Q&A, and I was wondering if there's questions out there and/or questions between ourselves as well, too. And I know it's a crazily a huge amount of different sort of agendas that we're taking at. But I'm wondering if there's, thematically some ideas of technology and ideas of sort of where especially the sort of information, I think is going to take us as well, as far as resources and information of that sort. So I don't know. I think I'm going to just sort of float it out there for anybody who wants to take up that mantle of where is the future in the idea of wellness and technology and performance? Or Junho, I guess you have.
I think no. The Beverly raised the hand first. Yeah.
Yeah, just an observation. With all these presentations, they're all fabulous. But there is I see a common theme that kind of links them all together, and that is in kinesthesia. That the future seems to be going in a direction where movement and a kind of affect is conjoined, and this is becoming an element for design in the future, which has not been up to this point in a conscious way. Anybody has any comments about that? I'd love to hear it.
Yeah, I mean, Beverly, I'm just going to concur that, you're absolutely on point with that. I mean, and I think it is also where some of these issues that have been around for a while, the technology is finally catching up with the ideology of these things, be it pneumatics, be it, and again, past sort of one-off things that they are potentially becoming a little bit more commonplace, et cetera. And the idea of the function of the form and the function of the little simple machines, I think are really starting to become the mainframe.
Actually, perhaps as the historian in the group, I can actually bring us back a little bit. I am currently sitting in a 1968 experiment in affordable housing that was trucked up to the site in 2 pieces and bolted together. So yes, this is a future focus, but I think we also have lessons from the past that we could bring into the conversation. This was plugged into an electronic grid when it was new and nifty, but there are things that we can actually learn as well from the past.
Absolutely. There are models that we can use from the past, but also from the body. I noticed, Scott, with some of the deformed shapes that you were using when you were extracting air, that the shapes that began to emerge were in some cases rather gynecological. And that as a kind of referring to the female body as a source of inspiration and power, other than the way we've seen it up to this point, as we start looking at certain processes.
I wouldn't say that it was it's sort of a byproduct, not necessarily
No,
an
not an agenda at all. What I'm
of,
talking about is this is how bodies get formed. If you start looking, and I'm not talking about in the final thing, I'm talking about the processes and the various developmental stages those are the shapes that begin to emerge. And that's a kind of whole new
Yeah, I mean, it's the whole idea of thinness and double curvature is really where that comes from as well. And perhaps, for many, it has a feminine quality to it of sorts, but it's really also just a, some people are pretty curvilinear themselves as well. So again, it just purely was a byproduct of actually, just purely the process.
Right.
As well.
For me, this connects us with buildings in a way that's gratifying.
What I found, unique, social, it's like there's a lot of issues. It all goes back to some of the things that we experiment in materials, our profession. And there's a materiality aspect that ironically, we are showing the different elements that we individually are pursuing in a virtual realm right now. And it's the connectivity aspect seems to be what's keeping us apart, obviously, but to me, it emphasizes over and over again that ultimately, as much as we are doing our individual work conceptually and turning it and manifesting it, I find it, I'm going to do it, I guess. I'm just going to keep harping on that people need to know about the fact that we are the experts for connecting the virtual, connecting these idea-driven ideas and turning them into something that is going to change our lives for the better, bring more equitable outcomes for homelessness, for justice, all of these things. I find that every one of us is dealing with ideas, ideologies, concerns. We're turning them into something that's materially going to be turning into something that's going to change everything for the betterment of civilization. If I'm going to bring it all together. June?
So, hi, my name's Al Edwin. I have a follow-up question to that. I know 1 or 2 people on the screen, and I feel like the environment of this group is an academic environment. And I come from the field. I'm currently working in modular construction in Los Angeles, and I'm very interested to hear how, Meredith, I think you were the one just speaking. I'm really interested to hear how the studies and the results of this group, it can be or is being transferred to the practical world in the field right now, or as products are developed. I was really fascinated by Scott's extruded, it looked like a roof layout for a module, that last screen that you showed, Scott.
Yeah.
And like, that's a great example of something that I would love to implement. And I just wonder, what is the process from taking that from the concept that you have on your screen? Do you have to get an ICBO rating or
Yes, that's a totally you're exactly right, and you know, the whole LARR and hilarity of that nature. You know, and I know Jen's dealing with you know, the cross-laminated timbers, which are also super hilarious to me. That you know, the LA building departments, you know, no offense, is quite retroactive in its nature, and thus there's a number of testing, et cetera, that too. But that's pretty far out there, I would argue. You know, even just looking at cross-laminated timbers, it's crazy how many, you know, actual legitimate, fantastic functioning buildings there are, and it's still not necessarily a you know, checkbox in the Los Angeles Building Code as well to go. But anyway, I digress, and yeah, those are great questions. But yes, it's probably a longer process than I was hoping, and you would think, though. So, you know, again, the prototype is first, testing the prototype, then eventually maybe you know, getting it into production is another.
is there a set of procedures that are I don't know, standardized to take a product from concept to use in the
Yes
field?
and no. No, I'm going to, you know, and I'm going to be frank, no. In LA, it is there are, you know, sort of the ICBO, but it's always some other department signing it off on it, not necessarily the Los Angeles Building Department itself, though, too. So yes, there kind of is, but each one of these are in different formats.
So from my experience, when you have, when somebody develops a really great idea and the industry is begging for it, then it takes an investor to put up a big chunk of cash to go through all the testing, and somebody has to push it through.
That is absolutely correct. And you're right on the, literally right on the money with that as well.
Okay, so so I have a question actually. Yeah, the Bing Hu, I think you gave us a really good presentation. So I believe that project is based on a kind of interdisciplinary setting, and maybe you invite some public people from public health domain and also public policy. So, but as compared to your research scale, my research scale is very nano scale. It's a very micro scale, the microclimate control for a individual workplace, individual classroom or patient room. So how can what kind of effort should I make to integrate the research domain and then your research domain so that I can get some intellectual benefit from your work?
First of all, Johan, I want to thank you to invite me into this panel, and it's quite interesting. The faculty in your school does fascinating. In order to answer your question, just want to give you the quick background information why we did what we did for the COVID. It's because I actually work. Before the COVID, actually work on smaller scale, individual building scale. We do measurement and monitoring. But since the COVID, we can't really go to the lab So we just want to see what else we could do using our analytic skill and look at the big data. And especially for me, this is an unavoidable trend, because usually for the health, especially for this kind of infectious disease, has a huge impact, societal impact. You have to look at the big data. And one thing we are trying to do is, after we get the result, how we can validate the result, the big scale result in the individual level. So if let's imagine we create a population level model to predict or monitor the health outcome at a population level, right? And then we use the individual monitoring data to calibrate that larger scale model. Then we can have integrated the two different scale research. And also our model will get better and better. Imagine this is almost like a training, the AI. You have the training set and they use more granular data to verify the AI model. So in this is actually a lot of interdisciplinary team are doing similar work. But it's a long way to go, just because the two scales too different.
I see.
Ming,
So
I think I have a quick follow-up question on there, and this might be extremely unpopular as a question, but I from your data and everything, I know that there's issues, regarding the situations and demographics that people are in. Is there findings on, is there solutions, or is there subsets, not just demographically or quote unquote culturally or anything of that nature, that sort of points you to how to relieve some of these the COVID-19 problems?
Yeah, thank you for asking. Actually, I did have that I did not have time to present. So basically we look into the hotspot we identified based on our model to try to understand why this hotspot, what causes, right? So it turns out a lot of relate to occupation, relate to the type people do, and also family ties they have with DC. And also for DC, it's also related to the foreigner-born ratio, probably similar to Los Angeles. So based on that, we did propose a set of recommendation to the DC government, including provide more mobile clinic and movable clinic in those particular zip codes. And as I said, we made a lot of outreach effort to the DC, different DC agency. No response. This is, again, it's a political thing, purely political things. Like for us, we don't want to get into any of this. We just want to get the information to their hands. It turns out our prediction is pretty correct. And the last thing we did is social media shame them, but it still did not work. So again, our lessons learned is really, if we really want to contribute to improve human health, it has to be large level. Somehow it has to be top down. The government has to identify and realize this is a social issue. It's not for me, it's not a technology issue anymore.
So I have a very naive question. So current social distancing, the 6 feet, is it still good or not? Or it should be much further or shorter, or based on your any experience?
You ask.
Oh yeah, Ming. Yeah.
We
6 feet is good still, or?
We did not include that in our model. Because this is getting
3 or something like it. Hasn't CDC changed it to 3 or something? Is that why you're asking?
Is it?
Yeah.
It's our model is just the key finding is not really the distance, actually the duration. The duration you are around people.
Makes sense.
So this could be interesting study for the medical people, medical researchers to look into.
Okay, great.
I'm
Actually, yeah, go ahead.
Sorry, I'm actually noticing that a lot of us are trying to overcome obstacles like policy. And my case, I'm definitely fighting Congress. But I'm just wondering, like, and then there's like building codes, ISBO. I think the question, I guess, is like, you know, I feel like we're doing, we're going back out. Are we out? Wait, what happened?
Somebody's sharing screen.
Oh.
Oh,
That would be Michael Husak.
oh okay.
Oh.
You know, Mina, I want to, you know, it's interesting. This is an article, and there's articles all the time in the paper about policy. You just said policy, and you also said that we want to get across to lawmakers that we're the experts. So my question is this. By the way, this little article here in the New York Times is about how the National Association of Home Builders are fighting sustainability, let's call them features in homes, because they're going to raise the cost of a starter home by $1,500. So, however, it will save the owners of those homes thousands of dollars a year. So this is my question. If we as schools, if this academic approach to this, you know, there's I'm going to call it the hard research, everything that we've seen today. But then, you know, where are the coalition of schools that write the editorial that say this should not happen? There's another initiative where the city of LA is being lobbied to eliminate all gas hookups in future buildings. Where is the School of Architecture saying that that's a bad idea? So if we want to be listened to as experts, Mina, as you say that we want to be, right? We have to, in other words, we can't design
Sasha, what's going on, man? Oh, I think you're muted.
Yes, I had technical difficulties, obviously. It's better now?
It looks like your internet is frozen as far as the screen goes, or it's very choppy, I see now. But
I might have to turn off my video.
Right, that's probably correct, yeah. So
is it better now? Can you hear me?
It's super smooth. I can hear you.
Okay, I'm sorry.
Now. Oh, no, that's fine. Yeah, you know.
Yeah, it's you know, it's 9 in the evening here.
Oh my goodness.
So that's peak time for Netflix all around the country. So the internet collapses sometimes at this time.
That's right. That's funny. Yeah. I love it. So what neck of the woods are you in?
In Zurich.
Oh, still. Zurich. Okay, great.
Yeah, but you know, we're planning the next window. We should be in LA since last summer, so it's really bad.
Yeah. Well, how is vaccination and all that going in Europe?
Not as well as I wish it would, especially in a pharmaceutical giant like Switzerland.
Yeah, exactly.
It's not happening yet. I mean, my parents got vaccinated today, actually. Finally.
Yeah, no, it is.
I hopefully in June, like end of May, I hope.
I think there's the majority, like 3 major pharmaceuticals are in Switzerland. It is headquarters. there. So
yeah, and actually one of like the Moderna vaccine is partially produced by a Swiss company here in Switzerland. So they messed it up. They took like 3 or 4 months to build up production capacity.
that's absurd.
But now I think they're starting now in April, and they will boost production from, I don't know, 20,000 a day to 2 million a day or something.
Yeah, that's good. I mean,
Hi, Melissa.
it's definitely been logarithmic here in LA, though, too, for a long while, at least. It was sort of this like gambling or something like that. I felt like, I was trying to get the initial shots, but now it seems a lot easier, though, too. So I think things, thank goodness, logarithmically come together. So
I hope so too, because my parents are the third group already. So, first 2 groups are the ones who want to are done. And hi, Avery. And so, I hope, like I said, end of May should be my turn somehow.
Melissa, I don't know you very well.
I know. Hi.
How's it going?
Good. Yeah, you have all of my students though for 411. So I feel like we communicate.
That's the Melissa. Okay, I get it. I know.
I'm not sure how positive they are, but
well, vice versa. I mean, what the heck? I'm teaching the freaking technical crap, and so it's like I keep on telling them, just do what your freaking design instructor wants you to do. I know it's oddball, etc., but that's what you got to do. And so, it's that's the agenda.
And then I tell them to do exactly what Scott says to do.
So yeah, I think there is definitely a little of this going on, no doubt. Well, Melissa, it's great to meet you in face to face. So now I know. That's very cool.
You too. Yeah, I think I've heard a lot about you because my first job in LA was working for Gary. So I've heard of you and Hervig, and I was kind of around SciArc for a little bit. So I feel like we've always been kind of,
right.
In
the mode, but not exactly overlapping. I guess my reputation at Frank's could be, it depends on who the hell you're talking to. If it's Tencho, or if it's Larry, or if it's Mock or any of these guys, and it might, again, it depends on who you're talking to.
It sounds like you guys had a lot of fun back then.
I mean, yes and no. I was the only fool that has a large lab, and so everybody throughout the day, and it's an open plan, space, or what used to be an open plan space before the warehouse thing as well. But and so you could hear Jim Glimpf on one side as the partners, and me on the other side, sort of laughing, throughout the office. So anyway, Avery, great job, by the way. That was good. It's hard to control these things. So, people going off on tangents, I think are.
I hope we were nice enough to just be like, okay, yes, we're going to answer your question, or we're going to answer your comment, but please let us talk. Exactly.
I know. I separately from every student, I think I got, what's going on? How come, this is not a student discussion?
We all had her, so it's we know it's fine. I just wanted to say it's been going well. I'm gonna go eat my lunch now. Good. But you've been doing a great job, and
thank you.
I hope that the overall you think what we said was okay and good.
Oh, fantastic! All of it is fine, and nothing of a. I'm gonna stop recording. Gosh, nothing of a weird.